Hide. All right. So, first thing we learned this year was coterminal angles. Remember that? Way back when? January? Yeah. Okay. How far are coterminal angles apart in degrees? 360 degrees apart. So if you add 360 to that, you get 408. If you subtract 360 from 48, it's negative 312. Sounds good. An 11-degree angle, what quadrant would that be in? 1. Convert this to decimal degrees. Okay, going back to decimal. You divide, not multiply, divide by 60. So take 11 divided by 60. Somebody calculador, por favor. So it's 62 degrees, 35.18. Give me a couple more. 3. And then take that part divided by 60, and you get 62 point, round to 4 decimal places. What? I don't think so. Oh, yeah. 5864. Yep. I was looking wrong at it. All right. So, basically, like that. Got it? Good? Good. Degrees, minutes, seconds. So now you take the decimal part, 0.617, and do what to it? Multiply by 60. 0.617 times 60 is 0.3702. Okay? 0.3702. No, it's 37.02. There we go. So this is 11 degrees, 37 minutes, and then you take 0.02 times 60. Then you get 12. 1.2. Yeah, round to the nearest whole number. 1. There you go. Converting degrees to radians. You multiply by pi over, not 2. How many degrees are in a circle? 360. How many radians? What's the circumference of a circle? 2 pi r, right? So 2 pi radians in 360 degrees. So 1 pi radians in 180. So this winds up to be, in the end, pi over 2. Cheyenne was just saying the answer right at the start, instead of the process of how to get to it. Pi over 2. Yeah. So convert radians to degrees. So instead of multiplying by pi over 180, we multiply by 180 over pi. Eat your pies. Multiply by 9. 9 times 37. 333. Which one is 7 pi over 6? A, B, or C? B. Find the length of the intercepted arc. Arc length. Is it on the board? At one time it was on the board. Over there? Yep. So this is in degrees, so it's a geometry one. So you go look under the geometry for arc length. Look under the geometry for arc length. So you go 21 over 360 times 2 pi r. Okay? And then punch it into your calculator. If it says 3 decimal places, you put the pi into your calculator. So 21 over 360 times 2 times pi times 45. And what do we get? 16.493. Okay, good job. All right, next, find the exact area of the sector of a circle. Now this is in radians. So if it's in radians, we use the radian formula for sector area, which is theta r, so pi r squared over 2. Is that what it says over there? Pi over 3 theta r. So pi over 3 r squared over 2. So, yeah. I don't know what that is. Don't put the pi in there. So it's 1/3 of 18 squared divided by 2. 1/3 of 18 squared divided by 2. 54 pi. I agree with you. Because I did that in my head while she was doing it. So I agree. Okay. How do we cancel here? Radian. Minutes. So you take 8 times 60 divided by 2, hit equals, and then divided by pi, hit equals. Okay? Or if you divide by 2 pi, make sure the 2 pi is in parentheses, because the calculator does order of operations as dividing by 2 times by pi instead of dividing by 2 and dividing by pi. So make sure you do it right. What do we come out to be here? Because we have revolutions in hours, so it must be revolutions per hour. How many revolutions per hour do we get? Round to the nearest tenth. What? 76.4 radians per hour. A windmill generating electricity has a blade 30 feet long. Depending on the wind, it rotates at various velocities. Find the angular velocities in radians per second for the tip of the windmill rotating 28,872 revolutions per day. And we want radians per second. So what do we multiply by? How do I get rid of revolutions? How many radians are in a revolution? 2 pi radians in every 1 revolution. Revolutions cancel. Now we have radians per day. I need radians per second. So I know that in 1 day there's how many hours? 24 hours. And in 1 hour there's 60 minutes. And in 1 minute there's 60 seconds. So you take 28,872 times 2 times pi, and then divided by 24, hit equals, divided by 60, hit equals, divided by 60, hit equals. And what do we get? Should I check? $2.1. Very good. Well, you say this is long? It's only 40 questions.
Is that how long the actual final is?
Yeah. For algebra 2.
3 hours. So we're just gonna review. Why did it take so long? Because it was long.
The blade on a table saw rotates at 3,300 revolutions per minute. So 3,300 revolutions per 1 minute. Calculate the linear velocity in miles per hour. So, how do I change revolutions to radians? 2 pi radians over 1 revolution. Now I have radians per minute. I need miles. How do I get radians into miles? Inches. Well, if it's an 8-inch diameter blade, what is the radius? So 4 inches is 1 radius. The radian and radius cancels. So now I have 4 inches per minute. I need to get it in miles. I know that there in 1 foot there's 12 inches. And in 1 mile, there's how many feet? 5,280 feet. Feet cancels with feet. Inches cancels with inches. I have miles per minute. I need miles per hour. I know that there are 60 minutes in 1 hour. Minutes cancel with minutes. I'm good to go. 3,300 times 2 times pi times 4 divided by 12 divided by 5,280 times 60. You do the math, right, Eddie? Okay. Just making sure that you're kind of halfway paying attention. Okay. Because it's amazing how much Grant pays attention, even though he does homework for every other class in Trig class.
I can do this.
Yeah, I know you can do this. Like I said, I was giving you a compliment. I said it's amazing how much you can pay attention, even though you're doing homework for every other class in here.
That sounds incredibly backhanded. Do you want
Yeah, I'll take the answer because I don't want Grant to backhand me right now. 78.5 miles per hour. All right. Oh, sines, cosines, tangents, cosecants, secants, cotangents. All right. There's a point at 5, -5, or -5, 5. So if we go back 5, up 5, we're right up here somewhere. What quadrant are we in? Second quadrant. Okay. In the second quadrant, we're back 5, up 5. What's -5 squared plus 5 squared? 50. Because it's 25 plus 25, which is 50. And if we take the square root of that, the square root of 50 is square root of 25, square root of 2, or 5 square root of 2. That's the hypotenuse of that triangle. It's a 45, 45, 90 triangle. Okay? So, how do we find the sine? Well, it's the opposite side from where the vertex is, where the origin is, over the hypotenuse. So we get 5 over 5 square root of 2. 5's cancel, so it's 1 over square root of 2. Can't leave square root of 2 on the bottom, so multiply top and bottom by square root of 2. So you get square root of 2 over 2. I've seen that before. Like on the unit circle. Maybe. So the sine is square root of 2 over 2. What's a cosine? Not quite. Not so fast, my friend. It's negative square root of 2 over 2. Okay? Because we're in the second quadrant. And whoa, didn't mean to do that. And because we're in the second quadrant, because this is negative, so you go -5 over 5 square root of 2, which is negative square root of 2 over 2. Tangent is -1 because it's 5 divided by -5. Cosecant is the reciprocal of what? Sine. Now, it was 5 over 5 square root of 2, so if we put 5 square root of 2 over 5 and cancel our 5s, what do we get? Just plain simple square root of 2. So secant is the reciprocal of cosine. Well, if cosine and sine look alike except for opposite signs, secant and cosecant should look like each other, opposite signs. And then cotangent is -1. Because it's, it's a 45-degree angle, makes it fairly easy. Yours on the test will be a 45-degree angle of some sort. How do we find the exact value of sine of -pi over 3? Well, what is -pi over 3? How many degrees is negative pi over 3? I know that pi over 3 is 60 degrees, right? So this is negative 60 degrees, which is the same as a positive 300 degrees. What's the sine of 300 degrees? Negative square root of 3 over 2? That's what it says on your unit circle, if you would have it out. Okay. What's the tangent at negative pi? Well, what's negative pi the same as? Positive pi. Tangent at pi. Well, at pi, tangent is sine over cosine, right? So it's the sine of pi over cosine of pi. The sine of pi is 0. Cosine of pi is 1. 0 divided by 1 is 0. Sine of negative 120. Where's negative 120 the same as? The sine of 240. What's the sine of 240? Negative square root of 3 over 2. The inverse cosine of 1, which is saying the cosine of what value equals 1? Where are we when the cosine equals 1? No. Where's the cosine equal to 1 at? It's at 0. 0. Where's the sine equal to 0 at? Not 90. 0. And also 180. But remember, when we're talking cosine, we go from 0 to 180. When we're talking sine or tangent, when we're doing inverses, we go from negative 90 degrees to 90 degrees. So we never get over to 180 for that. All right. Use a calculator to find an acute angle that satisfies that. What would you do on your calculator? What buttons would you push? Inverse sine. So second sine of 0.1732 is what? What? 10.0. Last one that we're going to do today. Find the exact values of sine, cosine, tangent, sine, cosine, and tangent. What are we missing in that triangle? Side A. How do we find side A? That's the what theorem? Pythagorean theorem. 25 squared equals a squared plus 7 squared. So 25 squared is like 625 equals a squared plus 49. Subtract 49 from each side. 576 equals a squared. Take the square root of each side. A equals 24. So the missing side is 24. So now that we have that, this makes a super easy problem. Sine of 24. Opposite over 24 over 25. Cosine of alpha, adjacent over hypotenuse. 7 over 25. Tangent of alpha. Opposite over adjacent, 24 over 7. Sine of B. 7 over 25. Cosine of B. 24 over 25. Tangent of B. 7 over 24. There we are. Okay? Cool. So we'll start with number 21 on Tuesday. Out there on the internet right now is a sample test that you can like do some questions on, see how you do, all that. You have to get it all the way done before you see how you do, right or wrong, but you can take it multiple times. There you go. You know, because not like